everybody. Welcome to the beginning of Unit 2, which you are starting virtually. So, everybody, grab your snacks, crack open a nice seltzer water. Mm, the Trader Joe's blood orange and orange. Is it delightful? It's all right. It's no LaCroix, but we'll do with what we have. Today, we're learning about the basic properties of addition and multiplication. So let's get rolling here. Really just some properties today. We're going to also use these properties to talk about how and why we can combine some like terms. So away we go. So the first two things we're going to talk about are the associative properties of addition and multiplication and the commutative properties of addition and multiplication and what these mean, how we see them, and things like that. So let's start with the basic definitions here. So the associative properties of addition says, well, if you have A plus B in parentheses, and then you add C outside of your parentheses, that should give you the exact same thing as A outside your parentheses plus B plus C. Basically saying if everything is addition, it does not matter the order in which you do it or where your parentheses are, right? You can do your A plus B first. You can do your B plus C first. It does not matter. So let's test that real quick. If we do that, let's throw some real numbers at this thing. So let's say 2 plus 4 in parentheses plus 6. Is that equal to 2 plus 4 plus 6 in parentheses? Okay, well, let's take a gander. Let me get a different color here. Well, 2 plus 4 we hopefully know is 6 plus 6. Is that the same thing as 2 plus 4 plus 6 is 10? Well, 6 plus 6, hopefully we recognize that gives us 12. And 2 plus 10 also gives us 12. So, hey, look at that. 12 equals 12. We're good to go. Okay, the multiplication one tells us essentially the same thing by our definition over here. But instead of adding, we're multiplying, right? So instead of A plus B plus C, we're going to say A times B. And yes, that dot stands for multiplication, times C, equals A times B times C in parentheses. And if we take this over here, we should find that the same thing applies, right? 2 times 4 times 6 should be the same thing as 2 times 4 times 6 with different things in parentheses. So in the first set, it's the 2 times 4, and the other set is the 4 times 6. Let's test this real quick. We always want to check and make sure we're not just making things up in math. So 2 times 4 is 8 times 6 equals, is that equal to, I should say. Let me go back and add a question mark because we don't know yet. We're testing it. Okay, so there's our question mark. Switch back to green. There's our question mark. We're asking, is this true? Is that the same thing as 2 times, now it's 4 times 6 that we're doing. 4 times 6 is 24. Well, hopefully we recognize 8 times 6 is 48. And 2 times 24 is also 48. So yes, again, it does indeed work. So your associative properties, again, they tell you basically it doesn't matter where your parentheses are as long as it's either all addition or all multiplication. You can do whatever you want first. Moving on to our commutative properties. Okay, addition tells us that A plus B is the exact same thing as B plus A. Again, essentially saying the order in which you add things doesn't matter. And again, we can test this. If we throw some numbers at this to double check and make sure this works. For addition, let's say we have something like 2 plus 4. Is that the same as 4 plus 2? Well, I certainly hope you're saying, well, Mr. Kaplan, 2 plus 4 is 6, and 4 plus 2 is 6. How about that? It works. Great. Same idea with multiplication by saying A times B, or AB, is the exact same thing as BA. Hopefully this one, again, is a little bit more obvious to you, right? But again, if we throw some numbers at it, we're saying, okay, well, 2 times 4, is that the same thing as 4 times 2? And hopefully, again, you recognize, bing, bang, boom. Both of those situations give me 8. All right, so you can tell the order that your numbers are in does not matter. So those are your associative and commutative properties. These tend to be a point of confusion, right? Sometimes we say, or we ask, okay, well, Mr. Kaplan, how in the world do you expect me to remember which one is which? Okay, well, the answer is this. Think about it as in, have you ever heard the term commuting to work, right? If you're commuting to work, you're moving yourself from your home to your work, right? So your commute to work is all about moving. So is the commutative property. You're moving things around, moving numbers around. Alternatively, your associative properties, we're talking about associating and what things are associated with, right? Well, parentheses mark what numbers or variables are associated together. So you're changing the association, right? In this one, A and B are associated together. In this one, B and C are associated together, but it doesn't matter, right? Well, that's what we found is it doesn't matter. So that's how you can kind of keep these straight. The commutative property is all about moving things. The associative property is changing what's associated, moving those parentheses around. Cool, cool, cool. Moving on. In the sum A plus B, A and B are called blank. So first of all, let's draw our attention to sum, right? Remember, when we're talking about sum, that is addition. That is the answer to an addition expression. Product, while we're at it, is the answer to a multiplication expression, right? You also have difference, which is subtraction, and quotient, which is division. But right now we're going to stick to sum and product because that's what our properties up here are talking about. So something you should know is that in a sum, the A and B are what we call summands. Summands. Summand you should know about that is, I don't know where that word comes from, but there you go. In a product, right, A times B, AB, A and B, this is a word we'll definitely recognize, especially from last chapter with our factor trees, but those are called factors. And there you go. And there you go. So just some good terminology to know. Can't get these things to go away. There we go. Now let's talk about how we actually use these. So these are things that we kind of already know, and now it's just a matter of putting a property title, a proper title with them, right? So now we talk about how we use these, and this is all stuff we hopefully know how to do. If we've got 43 plus 78 plus 7, right? We know how to do that. And a lot of times we use these properties in our head, but now we're going to see, well, why it works, right? Hopefully most of us look at a problem like this and say, well, 43 plus 78 is a little challenging. However, I see a 43 and a 7, which is a little less challenging. So what we can do, and again, like I said, we do this in our head pretty often, but we can actually use the commutative property, and this isn't a step you'd usually show, but we can say, okay, well, I'm just going to change up the order here and say, well, what if I make this 43 plus 7 plus 78 by the commutative property of addition? Okay, the commutative property of addition. Later down the road, we can go ahead and shorten that. Usually when I write this out, as long as you know what you're saying, and that's why I'm doing it the full length this first time, but if you just write com for commutative and a plus, so I know you're talking about addition, that's fine. But it is, both of those pieces are important because we want to differentiate between commutative and associative, and we also want to differentiate between addition and multiplication. Okay, so those two pieces are important. But that's what tells us we can do that. And we say, oh, well, I did that because I know 43 plus 7 is 50, which was nice and easy. And now that 50 plus 78 is going to be much easier to add. Well, what property allowed us to actually add together the 43 and the 7? Believe it or not, it's actually not the addition property. The addition property is something we'll talk about down the road. This is actually substitution, right? We know, I'll show you why, we know just from general mathematics that 43 plus 7 is equal to 50, right? So we've basically substituted the 43 and the 7 for that 50. Okay, we've performed a substitution because this is just mathematical fact up here. So this is the substitution property. It's not one of the properties we talked about above, but it is one you'll see a couple times in your homework, so it's good to know about. And then it's going to actually be substitution again, right? Mathematical fact tells us that 50 plus 78 is something, and we're replacing the 50 plus 78 with that something. Well, 50 plus 78, like I said, is going to be much easier to do now that we've made that 50 a nice, well-rounded number, right, with our first addition. So 50 plus 78, well, 50 plus 70 would be 120. So 50 plus 78 must be 128. And there you go. That was also substitution. So that's kind of how we use these. And again, it's a lot of times it's stuff we do in our heads, but it's good to understand, well, that's why this works mathematically. Okay, now we're going to talk a little bit about like terms, right? And this is also important for our like terms. So we're going to use the associative and commutative properties here. And we're going to start with our commutative property. The idea is, if you remember from pre-algebra, hopefully you recognize, well, this 9m is what we would call not alike with the 7 and the 5, right? The 9m has a variable, which makes it unlike the 7 and the 5, which do not. So when we're combining like terms, we want to combine things with similar variables or lack thereof, meaning we can combine the 7 and the 5, but we can't do anything with that 9m. So we're going to use the commutative property of addition. Notice I shorten it, but I still have the commutative property and the addition sign. And we're going to move some things around. So we're going to say, okay, well, what if we actually change this to, change back to blue, 9m plus 7 plus 5. Okay, now those are a little closer together. Then using our associative property of addition, notice I shortened that too, right? The associative property, I abbreviated a little bit, but it's still important that it's associative and addition. Now I can say, okay, well, this is really 9m plus, and we'll put this in parentheses to recognize that we should do that first, plus 7 plus 5, which is, by substitution, because again, it's just mathematical fact that 7 plus 5 is 12. Therefore, we're going to replace the 7 and the 5 with a 12, so 9m plus 12. And that is what that simplifies to. And that's why combining like terms works, is because you're able to move numbers around and reassociate them to figure out what you're going to do first. Pretty neat. I hope you like that as much as I like those terms. You know what I'm saying? Here we go. Next one, so with multiplication, notice you've got a 2x, a 3y, and a 4z. Okay. With multiplication, you're probably sitting there thinking, well, I can't do anything with those because none of those are like. One has an x, one has a y, one has a z, which if this were addition, you'd be absolutely correct. But with multiplication, like terms doesn't really matter. What you can't do is you can't multiply an x times a y and get an actual answer from that, because x times y is just x times y, right? There's nothing really to multiply. But what we can do is by the associative property. Actually, we'll do the commutative property first, my fault. We're going to change this to 2 times 3 times 4 times x times y times z. So we get all of our numbers together. And again, that was by the commutative property of, this time, multiplication. Okay, the commutative property of multiplication allows us to move those things around. And now we're going to say, okay, well, let's put those numbers, 2 times 3 times 4 times x times y times z. That is your associative property of multiplication. And then we can actually multiply the numbers out. Again, you can't multiply the x and y and z. That's just going to remain x, y, z, right? Because x times y, again, is just x, y, right? But you can multiply 2 times 3 times 4. So 2 times 3 is 6, and 6 times 4 is 24. X, y, z. And that is how we would simplify that one. That is, again, by the substitution property. So hopefully that makes sense. Your homework's going to have a lot of simplifying, combining like terms, and telling me what property allows you to say that. And generally speaking, and by generally speaking, I mean always, it should be one of these 4 properties. Oopsie. Either the associative property of addition, associative property of multiplication, or commutative property of addition, or commutative property of multiplication. So you're basically just listing one of those 4 things that allows you to make that simplification and go with it. There are 3 more that are what we call properties of equality. Okay, we've got our reflexive property, the symmetric property, and the transitive property. So I'm going to tell you what each of these are, give you an example of when you'd actually use them or what it actually looks like, and then we'll be done for the day. Not much more. Don't forget to go ahead and do the 2.1 homework after this. It's the one labeled homework number 1. So take a look at that after this. it looks really long. Yes, there are a lot of problems, but you'll find that each problem really only takes you a handful of seconds, especially if you're going ahead and shortening, abbreviating the associative and commutative properties. Each one of those problems should really only take you a handful of seconds, especially once you start getting the hang of it. So before that, let's finish this up. So we've got a reflexive property. Look, this one, guys, is so simple. You might call it a reflex. You know what I'm saying? Okay, good. All this one says, and it's so unbelievably simple, but it says that, oopsie, A equals A. Yes, it is that simple. It is very much just saying that a number equals itself, which sounds like a property we shouldn't need to include, but it is. So literally it's saying something along the lines of, if you have the number 4 is equal to the number 4. Why we need it? Because math. There you go. It is really and truly that simple. When you're wondering how to remember this one, it is quite simply because it is so simple that it is a reflex. There you go. Moving on, the symmetric property says that if A equals B, then B must also equal A. We call this the symmetric property because if you think of a line of symmetry, right? Let's draw a triangle with a line of symmetry. The idea of a line of symmetry is you could flip-flop the sides and they would end up being the same thing. Well, the idea here is the exact same thing. You could flip-flop A and B and they should be the same, right? And this is something, it seems like something we've never used before, but at the end of the day, we use it all the time when we're solving equations. How often have you done an equation and you say something like, okay, well, I've got 14 equals 2x. If you divide both sides by 2, we get 7 equals x. Oh, well, I like to have my x on the left. That's usually how we write our math answers, so x really equals 7. You actually just use the symmetric property right there because you flip-flop sides. No big deal, right? So it's the same thing as saying if 7 equals x, then x equals 7. And again, it's another one of those ones that is so simple that we do it oftentimes in our heads. Most of us wouldn't show both of these steps and we just jump right to this step, but that's okay. What allows us to make that step is indeed the symmetric property. Transitive property is a little more complicated. What I like to think of this is I'm making a train. It says tran, but we'll pretend it says train. A train of my long steps here, okay? So what that means is if A equals B and B equals C, then A must also equal C, okay? So we use the transitive property a lot when we're simplifying expressions, right? We basically said, hey, if we look back up at number 2, at the very end of this, we could say, well, that means 7 plus 9m plus 5 is equal to 9m plus 12 because 7 plus 9m plus 5 was equal to this, and this was equal to this, and this was equal to this. So our very first thing must be equal to our very last thing by the transitive property. We made a train with our steps, so our first thing must be equal to our last thing, okay? We use this a lot. I'll give you a really basic example with simplifying fractions. Let's say you get to the end of an equation, you say, well, if x is, let's say we end up with something like 2/4, which we hopefully recognize, well, that's 2/4, well, and 2/4 is really 1/2. Well, that means that x, right, we've got 2/4 and 2/4, that means that x must really be 1/2. Then x is 1/2. Sorry, I didn't do that in red like the others. But that's the idea here, right? We've got something is equal to something. We know that something is equal to something else. So our initial something must be equal to that something else. And those are your initial properties. Okay, those are your initial properties. If you have any questions, feel free to send me a Google chat or an email. I'm happy to answer them. We will also talk about these a little in class at our next meeting because I know it's a little different having to follow along with a video lesson. Please, once you take these notes, go ahead and upload them. We're going to try and stay a little bit more on top of it this time and try and upload things as we go this unit. So go ahead and upload them to your OneNote. You'll notice all of you have a Unit 2 underneath your names now under assignments, assessments, and notes, right? Go ahead and upload those to your Unit 2 folder, and then you can start on the 2.1 homework and start working through that. This one don't upload quite yet because I want you to have the opportunity to ask me questions in class tomorrow, and then we'll upload it. Okay. So with that, I hope that that we're feeling good about this. And again, if you have questions, let me know. But other than that, best of luck, and I'll see you soon.